So the nuclear power, I was very lucky to get data from the Japan Atomic Energy Agency. They provide me with a detailed model of nuclear power plant. So this is just an example. And this is where you put your radioactive elements here, and some part at the top is where they put the radioactive fuel. So these are analyzed together with so that earthquake and this nuclear power plant is analyzed. So this is how it deforms with that earthquake. So this is probably a simple case of analyzing it, because I used only what we call elastic analysis. There's still other more complicated analysis procedure that can model fracture or some plastic behavior. And I actually would like to extend this analysis to urban area. And for example, this is the urban area of Niigata, and this is where the Niigata Shinkansen Station is located. And this area alone, there are about 180 buildings from medium to high rise. And next slide, can you click? And I simulated the scenario earthquake based on the active fault nearest this area. Okay. So this is how the buildings behave. As you can see, some buildings move on one direction, other move in other direction. So this is very much related to its configuration, its material property. Some are made of steel, some are made of concrete. So this is what I'm studying. This study can be used for estimating possible damages, as well as evacuation of people in times of earthquake. Some from our research group is working on, for example, after this simulation, there's a tsunami coming over here. Okay, so for this analysis, I'm using the fastest supercomputer in Japan, but it's currently the fourth fastest in the world. There's about equivalent to about 80,000 processors if you use all of them. 80,000 computers with 8 cores inside. Usually we have a quad core, but in this case there are 8 cores inside. And so the total is about 640,000 cores. And for that simulation alone, I use about probably 1/10 only. So there's still a lot of room for analyzing larger models. And just to show how big one cabinet is, so this is one cabinet. There are about equivalent about 90 computers in one cabinet. And for reference, we are the same height, so around 7 feet. 7 feet. So, I think now I'm solving this model. You can see this is like half part of Japan. This, just creating the model for this uses around 1/3 of the computational power of the K computer. And until I go back to the Philippines, probably 1.5 years more, I'll be working on this model every day. So it will be my breakfast. So, simulating large earthquakes, possibly including the 2011 earthquake. I don't know if I will get a good result or not, but because it's really highly dependent on the models that we have that we get from third party. And, yeah. So that's actually my last slide. So I would like just to introduce Niigata. Probably only some people have been there. This is a picture in spring, summer, autumn, and winter. I recommend the sunset in Niigata. It's very, very beautiful. But the winter, no. It's terrible. So I think that's the end. Thank you very much.
Question.
Maraming salamat, sir. Sino po ang may mga katanungan habang nandito pa si Professor and masasagot po niya? Ako po, ang dami ko pong tanong.
Okay.
Alam niyo na. Hindi gets. Ang dami ko pong tanong, sir. Ano po ang ano naman po ang magiging, paano niyo po dinevelop yung mga supercomputer? Sabi niyo nga, parang may mga codes kayong dinevelop. Paano niyo po siya, ang tawag dito, ipapakalat? Kailangan ba yan ipaalam sa maraming tao? Makakarating ba sa Pilipinas yung dinedevelop ninyong technology?
Yes, yung isa sa mga goal nung pag-develop namin ng mga codes is para dun sa future na technology natin. For example, now I'm running only on 2 gigahertz processor. Probably your laptop is way much faster, 3 gigahertz probably. Probably that ThinkPad or Toshiba is 3 gigahertz. That's actually faster than what I'm using right now. The only difference is that I'm using a large number. So now, if we can create a very efficient code that can be run on laptops, that's the main.
So pwede na siya maging available
Currently,
for everyone?
currently no, because hindi kami nag-dictate kung kailan namin i-release. Medyo yung, ang tawag dyan, yung ownership ng research na to is nasa government pa.
Okay.
Pero meron kami develop for basic understanding of like how structure is found. Yeah, mga simple programs that are also efficient na pwedeng i-run sa mga ordinary laptops or pwedeng i-apply sa different scenarios. For example, sa Philippines, meron tayong earthquake hazard sa Manila.
I think big Project NOAA is
Project
doing...
Project NOAA is